Good afternoon and welcome everyone to today's webinar. It's part of our autumn series with Frazer-Nash Consultancy, specifically with Zack Seymour presenting for us today. The topic we're going to be looking at is their new UP rating or UP rating. I've yet to actually ask Zack which way around it is. A new method for judging pilot competency for test flight operations. It's going to be an extremely interesting presentation, having seen a glimpse of it yesterday, and I'm much looking forward to it. Zack has been with Frazer-Nash for 3 years and is one of their senior engineers in the UAS department. So we're delighted to have you here, Zack. And I shall hand over to you. Once the presentation is shared, I'll duck out and turn my own camera and microphone off.
Oh, thanks very much. I'll have a go sharing this slideshow. Please let me know if that is sharing. Yeah, the classic Teams.
That is, yes, all perfect. Thank you.
All right, then. In that case, probably get cracking. Make sure we can finish on time, go out for some lunch. Okay, so thanks for attending this webinar. As Eleanor said, we're going to be talking a bit about UAS pilot competency, specifically from a R&D or development sort of perspective. And I'll get into a bit more of that in a moment. So don't want to spend too long on this slide, mostly because that's quite an old photo, but a short introduction to myself. As Eleanor said, I've been at the UAS or Uncrewed Aerial Systems group at Frazer-Nash for about 3 years now, coming from a aerospace degree at Loughborough University. In my time here, I've done quite a lot of, well, we call it 3D, so design, develop, demonstrate, but things like novel UAS design and evaluation, and then sensor/software integration and test on drones. So looking more of that development or custom bespoke type end of things. On top of that, I'm also the quality manager, very grand title, for the Frazer-Nash UAS flying organisation. And as part of that, my remit is managing updates to our ops manual. Similarly, doing our CAA applications for PDRA01. And what drops out of that as well is this competence framework, which mixes those last two things of project experience and our flying org and my role within that. I'll try and keep this a bit short as well, but introduction to what Frazer-Nash US team does as way of context of this. So Frazer-Nash, it's a medium to large systems engineering and technology consultancy. Within that, the UAS team, so Uncrewed Aerial Systems, have these 3 key service offerings. So we've got what we call UAS expert advice, or we can sort of think of that as traditional consultancy on the left there. And then we have 3D, so design, develop, demonstrate as the 3 Ds there, or R&D type work. And on the side, we have sort of flyals and trials type activity, with our CAA qualified pilots. And it's really in these last two, where we actually operate drones, that a lot of this stems from. So we go out, we do flying, but the complication is the types of flying we do is not, it's not business as usual. And because of that, it poses some new questions about how we do it safely. So within the 3D, it's often quite low TRL or quite complex types of missions that we're conducting, which doesn't lend itself particularly well to the GVC from a pilot competence perspective. And then from a flying and trials perspective, it's typically higher TRL, so more mature platforms, but then also higher pressure. So obviously you're out in the field, you're being paid to deliver a successful demonstration for a client. There's a certain amount of pressure on the pilot to try and make sure that goes well. And again, we felt that that sort of situation wasn't particularly well covered by the standard training within a GVC. And that brings us quite nicely on to the problem that we're trying to solve. So essentially, in accordance with the implementing regulation, so I've cribbed a line from that here. So the actual legislation that we have to follow says that as a UAS operator, we have to identify what the competency requirements of our remote pilots are, in addition to the GVC. So taking the GVC is almost as a starting point, especially for the specific category, and then building on top of that to try and determine what sort of competence you need a pilot to have. So obviously the GVC, it's, from our view at least, it's mostly aimed at COTS, commercial off-the-shelf drones. I think rightly so. It constitutes the vast majority of commercial drone operations, so it makes perfect sense for the CAA to focus their efforts there. You also have things like the ECITB. I have to double check my notes are the Engineering Construction Industry Training Board. So they've developed a set of training materials for how to use drones on construction sites. So looking at safety procedures, best practice for getting the most value out of drones, specifically in a construction setting. What this does leave, though, is a bit of a gap that we've identified around more sort of prototype or research and development type activity, or experimentation, if you like. It's a bit of a niche area, which is probably why we haven't been able to find anything currently available to tell you what is competent and what is adequately competent for this. And obviously with that legal angle to it as well, we have to have something, which is where we've gone and developed our own system for trying to assess what is competent and what do we mean by competent. I've spoken a couple of times about the GVC. The main reason for that is we've tried to follow the current practice of thinking of bolt-on systems for a GVC. We don't want to replace it. So things like air law or meteorology, we're not qualified over the CAA, that is, to say what that should be. And because it already exists, we don't want to reinvent the wheel. This is all focused at things that don't exist, well, or didn't exist, I should say. So specifically around research and development, or on the more sort of software autonomy side of things, where the platform itself is a bit more mature, but then the software that controls it less so. So essentially what we've done is come up with a framework as a tool to try and assess how competent someone is or how competent they need to be. So I guess quite simply, we do missions. A mission has a competence requirement, and that competence requirement should be met by a pilot. Obviously, there's a question of, well, what is competence? So we've decomposed this into skills, which is a bit more quantitative, yes, no, or is it experience, so qualitative? And then the combination of these two factors sort of adds up into your overall competence. Taking some inspiration from IP ratings or ingress protection ratings, we've come up with up ratings. It is up ratings. I'm not too precious of it either way. I just quite like the idea of upskilling someone. Anyways, that's a bit of a tangent. But essentially, you were saying an up rating is a snapshot of someone's competence consisting of skills in green and then experience in yellow. So decomposing again the skills into fixed wing skills and multi-rotor skills. Clearly, there's probably some overlap between those. So looking at things like VTOLs or slightly unusual platforms, there is a bit of overlap between the two, which we've also captured within this. I guess quite simplistically, you can say a really difficult mission or something that's really risky has a higher competence requirement and therefore needs a more competent pilot. We've defined all our missions, all our standard missions, I should say, in terms of what a competence requirement is, and then have a similar system of recording what competence ratings our pilots have. So in that way, we can use this framework as a tool to help choose pilots for particular missions or scope those pilots into bids or opportunities. I'll now spend a little bit of time explaining what we actually mean by skills or experience and what that actually looks like in practice, and then put them both together into a bit of a worked example. So starting then at skills, quite a lot on the page, I'll get through it. We've defined it as that line at the top, but it's essentially individual things that a pilot can be tested for. So a qualitative, yes, you can do this, or no, you can't do that. We've grouped our skills into sort of logical sort of progressions and different themes. So having building blocks that build on top of each other with sort of higher skill or like more difficult skills at the top, building on lower level ones below. In terms of grouping, we've also got what we call think our core skills. So that's all the big blue box on the left, consisting of practical flying and mandatory supporting. And then we've also got some optional skills. So these are things that are sort of nice to have, if you like, and things that doesn't necessarily have to be the pilot who has this skill, but someone in the ground crew on the day should have this sort of skill if the mission calls for it. In that way, we've got mandatory and optional supporting skills. So again, some things you have to have and some things that are nice to have. To sort of assign someone a skill level, you say they have to have essentially all the boxes up to and including their level within this left-hand side. I don't know if you can see my mouse. So the blue box, essentially. So like, for example, if you wanted fixed wing flying at level 2 skill, you'd need that box in the center at the bottom. So position, cruise, loiter, you'd need altitude hold, you'd need the auto launch and land from the automated side of things, and the waypoints, in addition to Teammate, which is our sort of system for doing an effective ops briefing, incident reporting, and log extraction. So a combination of those 5 boxes together gives someone level 2 fixed wing, just as an example. For people with a bit more, I guess, control engineering background, you might notice that the way that these skills progress is related to the underlying sort of control structures, with the idea that there's more levels of abstraction at lower skill levels. So essentially more sort of flight controller or autopilot assistance. Looking at the fixed wing progression again, you'll have like fully manual all the way at the top. So the pilot is directly controlling the servos and the motors to get the desired motion they're looking for, all the way down to things at the bottom like position or cruise mode, depending on what you're using, where pilot takes your hands off the sticks and then it just loops around in a circle, or it holds a constant ground track, with the idea here that as you lose sort of various sensors, or if you lose functionality, you essentially go up skill levels in a logical way. So as a risk mitigation piece, you could say, well, we want our pilot to be skill level 1. However, we think it might drop into a reversionary mode. So we're going to say the pilot has to have skill level 2 to mitigate that risk. Okay. So I guess looking a bit more into that, just one of these an example. So acro multi-rotor, like what is it? A bit of a deep dive. So for each of our skill blocks on the last slide, we've defined what it means and what a pilot has to be able to demonstrate to be able to achieve that skill level. The analogy that I quite like to look is it's a bit like a driving test. So officially, you don't need lessons to pass a driving test, although it's good to have them, obviously. What you really need to do is demonstrate on the day that you have the skill needed, and you can do that to an acceptable level. We've taken that sort of analogy and applied it to each of these skills here. So using this acro one as an example, what is acro? Well, it's also known as rate mode, and essentially where your control sticks control your rate deflection instead of your position. So effectively, if you have centered sticks, it's your attitude that is maintained with 50% throttle. And the effect that has is it's not self-leveling and there's no altitude control. Well, you can't guarantee altitude control, I should say, which is why this is the top level 5 skill, and other skills build up to this. We've got a few must-haves and should-haves. I won't just read to people off the screen, but it's essentially the idea that there are some things that a pilot has to do to be able to use this skill in practice for a real mission, and there are some things they should work towards, noting that we probably won't do them in practice. So performing a loop, it's probably a good demonstration of someone's skills in this mode, but I personally can't think of reasons why we'd need to do that for a business purpose. And that's sort of the key element to a lot of this. It's how do we formalize a lot of skills that people might have from a hobbyist perspective, and formalizing that in a business setting. So that's skills, a bit of an example. Moving on now to experience, and this is more of like the qualitative side of things, as opposed to the quantitative for the skills. What we do here is say, generally, if skills is you can do X, Y, or Z, experience is how likely is someone to put those skills into practice in the field. So essentially, it's a reflection of pressure that's put on the pilot for various reasons, and the pilot's ability to deal with that in practice. In that way, it's a bit of a risk-based decision. So both flying risks, traditionally, what's the damage that could be done, or what's the risk to life, but also a business or project risk as well. So those elements, while they won't necessarily impact like the safety of a mission, they do put pressure on a pilot, and we've covered that as commercial risk impacts on this slide. Each of these indicators, so this list of 5 on the screen of what we've chosen as like experience indicators, have a two-way dependency. So the idea is that putting a pilot into certain situations will build experience. You can't just do the same thing over and over again and expect to learn more. And then from the flip side, to be able to put a pilot into one of these situations, you want them to have the experience that's associated with it. So it's a bit of a two-way street on experience in each of these. I said it's qualitative. Essentially, the reason for that is a lot of this can be quite subjective. What we've tried to do here is produce some guidelines for someone applying this subjective decision, but in a slightly more consistent way than how good is John at flying or how experienced is he? Quite. So like briefly rattling down this list, we've got the size of UAS, how big and how scary is this drone that you want someone to fly. You've got commercial risk. So if this goes wrong, how much could it affect the company and the project? It could be a really expensive drone. Maybe you've got strict timelines to meet, and you have to have a successful demonstration on this day to be able to meet it. That sort of factor. You've got platform maturity. So this is quite an obvious one to me, at least. It's is this a commercial off-the-shelf drone that you can trust? So you push forward on the stick and it goes forwards, or is it a prototype? It's never flown before. You're doing its maiden flight, or is it somewhere in between? And again, that features in how much experience you want a pilot to have to deal with that situation. Location. So this is another one that adds pressure on a pilot. So how well does the person know the operating area, and how much risk does that pose to the mission? Is it your normal flying field that you always go, it's a segregated area, no one's going to get in? Or is it somewhere you've never been before, it's public access, you have to manage the ground risk a bit more carefully, and sort of all those factors that put pressure on the pilot. And then the final one that we've got is operation attendance. So this sort of reflects back to one of our key service offerings, which is like a trial service. You're doing a trial potentially with paying customers who are expecting success. That puts a lot of pressure on a pilot. On the flip side, let's say you're taking your prototype drone out to the field to test it for the first time. Chances are you're not going to have paying customers present to that session. Instead, you're going to have colleagues who are there to support you and help you. So again, it's a very different sort of pressure that's put on the pilot. But all of these things together, really, it reflects, how much do we trust this pilot to put their skills into practice. I said it was a bit of a sort of guided qualitative decision. And this is essentially how we're currently making that decision. So you've got our experience level, 1 to 5 across the top, each of our experience factors or indicators on the left, and a few descriptions of what that looks like in practice. And then the idea is that you take this, you'd say, okay, John, he's got, significant experience, 0 to 25 kilos. He's great on size, so that's number 5. But he's actually never done anything that adds a lot of risk from a project perspective. So we'll call that 1. Maybe he's never flown anything that's new or untested. He's only ever done COT stuff, so that's a 1 or a 2 perhaps. And then you keep doing that for each of the factors, and you should be able to come out at a more guided decision on what that experience is. And then at the bottom we've got this overall. So if you really can't tell, is someone 3, are they 4? This can help you make the decision. And again, like what we've tried to do is be quite flexible in how we've applied this. So what we don't want to do is say, absolutely no way is John ever flying this. We want this experience sort of indicator to be, okay, so John can't fly this at the moment because he's not particularly experienced. How can we then build that experience so he can go and do this? So it's about trying to help people get to the right competence standard as opposed to putting up barriers to people. Okay, so we've done skills, we've done experience, and then let's put that together, a bit of a worked example. So I said before, a mission has a competence requirement, is met by a pilot using a representative mission, so one that I went out on Monday of this week to do, the maiden flight of an experimental fixed-wing UAS. In our register, we've given that a competence requirement of up 5x4, so that's level 5 fixed wing, the top level for that. We've got X, not required, it's not a multi-rotor, for multi-rotor skill level. And then as a combination of all the factors I've talked about in the last couple of slides, so platform maturity, operating location, all that sort of stuff, we've come up with an experience level of 4 for this mission. And that really reflects the fact that in this maiden flight, we're not going to do this over a beach. We're going to go to a controlled environment that we can control, try and mitigate that risk, and therefore take a bit of pressure off the pilot. We then say, okay, we've got this competence requirement, 5x4, who meets it? I've used John Smith as the example throughout this, so I see no reason to stop now. But let's say John Smith is your only pilot who meets this competence requirement, but John's out on holiday. What do you do then? Well, you might have people who don't meet the skill level requirement, or you don't have the experience requirement. And in each case, this framework provides you a way to try and upskill them, if you don't mind my pun, upskill them towards where they need to be. Or it might be a case of accepting the risk with additional mitigations. So again, this is all about being flexible, running your flying operations correctly and in a mature and responsible way, and having a more sort of consistent sort of framework to be able to make those decisions. So what have we said here? So maiden flight up 5x4, Y5. Well, we want the person who's flying this for the first ever flight to have like direct control over the servos. So let's say fully manual for that and everything below it. You might have some problems on the day. You might need to do some root cause analysis using those logs. So let's say you want to be able to report any incidents that happen, extract the logs, analyze them, and come up with a root cause to whatever might be going wrong on the day. So that's essentially the reason why we've given this a skill level of 5 for this specific example. And then we've done that for all our other missions, within our register, looking at what do we need the pilot to do, which feeds into the skill level, and then how hard do we think it's going to be for that pilot to do those things, which feeds into the experience side of things. Okay, so just to recap, what have we done? We've identified a bit of a gap in the way of assessing competence, specifically for R&D or development type missions. To fix that gap, we've created a competence framework as a tool to assess who is competent, or sufficiently competent to do those missions and help the decision-making process. This is not doing the thinking for people, but it supports that thinking to happen in a consistent way. Doing this, we're bridging the gap between a business requirement to do a mission and then the people who are actually delivering that work. It's a fairly new system, so I think this is only approved internally. When was it? A few months ago. So it's fairly new. We're still learning as we use it on how to improve. And again, we'd welcome discussions on potentially how to improve this further, or even to adapt it to different users or different situations. What we try to do is produce quite a flexible and customizable, if that's a word, system that can hopefully be applied to other niche users. We're continuing to add missions to our library as required, and in that way we're building up a library of sort of standard operations, sort of using the sort of standard sort of in inverted commas, because the whole concept of this is what is non-standard, and it's trying to bring a bit of definition into what we mean by non-standard. Obviously, UAS technology continues to evolve, and we'll have to update our skills and experience definitions to keep pace with that, and we intend to do so. This is a live document, and it's something we intend to keep using in anger. Yeah. Any thoughts? Would be super happy to hear them. Likewise, if you want any assistance, perhaps in applying this to your own situation, again, please come talk to us. Let us know what you need, essentially. Do you want a cheesy quote? Let's go for a cheesy quote. So, definitely not written by ChatGPT, but the future of UAS is not just about technology, it's about the people who operate and innovate. Let's lead the way with competence and integrity. Okay, I couldn't help myself. But with that, I'll leave it there and sort of open the floor to the Q&A. My details on the screen there. I think they'll be shared afterwards. If not, feel free to take a screenshot, reach out separately if you need. I'll stop sharing the screen and open the floor to Eleanor to manage the
Indeed. First off, Zack, thank you. That was really interesting, and I think, as you say, it is. While that quote may have been cheesy, I think it's absolutely where we all stand, and particularly ARPAS as the association. Let me speak properly today. Association that promotes professional competencies, skills, experience right across the board for all those who are involved in the UAS industry. I like the idea that your uprating is upskilling people. It's a very clever way of putting it. And essentially what you're saying is that it all comes down to risk as to whether you then go ahead with somebody that by being able to assign skills levels and experience levels, both on a quantitative and qualitative basis, that you can ascertain what the risk is of using a particular pilot in a particular scenario.
I think that's probably a good way to summarize it. Essentially, we'll all do this sort of implicitly anyway. A lot of this is about sort of formalizing that decision-making process and making it a bit more auditable. So I guess one of the big ways you've come up with this system is sort of looking at sort of potential situations that might happen and go, well, what should we do, and how does the framework reflect that process? So I guess quite simplistically, you'd say we've just put a new pilot with no previous drone experience through a GBC. As an organization, we've said that's our baseline qualification. It probably wouldn't be a good idea to then hand them the controls to 25 kilos of untested, unproven drone. I think that's quite an open and shut case. Essentially, this framework is a way in that extreme case of saying, well, this person is clearly not competent or sufficiently competent to run that mission, but then also everything in between. So it's trying to make that slightly more grey decision of, okay, so we've had someone who wasn't in the same position, but that was 2 years ago, and now they've gone out and they've had some more experience. Now are they ready to do that mission? And the answer might be yes, might be no. This is a way of trying to reach that decision in a consistent way.
Are you recording how they gain their experience in a particular manner at all that matches against what you've set as the skills and experience?
I guess short answer is yes, we are. We have our own training register, training logs, all that sort of stuff, and then tying that into the different sort of skill levels, skill building blocks or experience levels that someone might have. I think I touched on the fact that the experience side of things is a bit more qualitative. In that case, instead of, yes, I've observed this person do this skill, tick off, yes, they've done it. It's more of a, here's my rationale as to why I think this person deserves to be an experience 4 rather than 3, or perhaps it's the other way and they would be a 4, but they haven't got this. So I recommend 3 for now, review it again in 6 months. And then that way you're sort of building up your trail of breadcrumbs, just so that, if anything does go wrong, and obviously not planning for it to go wrong, you've got something which backs up your sound decision making and sort of proves that you're not being reckless or irresponsible.
Indeed, so, yeah. It's the auditable side of things. Yeah, absolutely.
Exactly. Yeah.
So we have a couple of questions we'll work through. How would you discern between different levels of offboard risk, e.g. a multi-rotor rate controller is inherently more risky to test than offboard position control? How would you quantify risk for multi-vehicle missions?
Really good questions. Sorry, I'm having fun with the Zoom Q&A function. So I guess 2 questions there is sort of levels of offboard risk, and then what's the risk for multi missions? Yeah. Sorry, multi vehicles, I should say. So taking the first one, the approach we've taken here is from the pilot's perspective. So let's say you've got a team of people in the field who are from a software or sort of autonomy sort of perspective, and then you've got someone there who's on the controls. Essentially, if it all goes wrong, it's their fault. They are responsible for the vehicle. They are the commander in sort of AAIB terms. Essentially, the thing that all offboard modes have sort of the similarity between them is it's not just what the pilot wants to happen will happen. It's more about the wider system view. I think the example I've used in the past is, GVC test. Someone will say, the examiner will say, okay, pretend that you're doing a survey of this roof, plan your mission, do your operational briefing, and then do the mission as if you're looking for, I don't know, some like dodgy roofing tiles, for example. In that sense, the pilot has sort of full control over, what the mission looks like, what exactly the drone does while in flight, and then because they know those things, they can give quite a comprehensive brief on what the mission is. From a offboard perspective, the sort of focus changes from, instead of I shall control the drone, it's if the drone goes further than this position, my fallback action is to take control, return it to the landing site, or it's trying to understand from that software team what should happen to be able to notice when it's not. We see the sort of the key function of what we call like the safety pilot. So the person on the sticks while you're testing offboard modes is primarily to protect people. You don't want to fly away. You don't want to crash into something or someone. But then the second thing, which is protecting the drone and the project from that. In each of these ways, if it's a rate controller underneath, or if it's a position controller underneath, the pilot should be able to understand what the intended action is, and therefore how to notice when that's not happening, and what to do because of it. So I think Well, so that was a really long answer to essentially, I don't think there is much difference. I think, yeah, the risk is different, but from a pilot competence requirement, which is the key focus here, it's a lot of the same skills and experience being used. Multi-vehicle, the short answer to this one, we've not done multi-vehicle work internally, so we haven't got a sort of an entry in our library of what is that rating for multi-vehicle missions. And it sort of goes back to what I was saying of this being a live system that we'll continue to use and update and improve. Maybe a bit of a cop-out answer on the second side, but
and then our next question is, how are you looking to update this system to accommodate the forthcoming updates to the CAA's remote pilot competency framework?
Sure. So from the previous consultation, we see the main focus of the CAA's updates to their remote pilot competency as looking at sort of business as usual BV loss and the risk associated with that, and then also throwing in some swarm activity. Taking a look through that consultation and noting that it's subject to change, we don't see R&D as the key focus for the CAA. On that basis, a lot of the things that I presented today on the skills and experience and the system of matching those to a competence, to a mission, to a person shouldn't change significantly. Obviously, it might the new competency framework might come out and that could turn it all on its head, but we don't see that as a significant risk.
Interesting. Will you be looking to engage more on that side with the CAA?
I think so. I guess the main benefit is what I said earlier about not reinventing the wheel. So we've approached this from, let's not waste effort by trying to reinvent what already exists. But I guess the same could be true from the flip side. So again, we'd be perfectly happy to share a lot of this thinking with regulators to try and guide some of that sort of regulation around what we're calling non-standard missions. Obviously noting sort of financial limitations, particularly at the CAA. I don't imagine this would happen particularly imminently. But yeah, obviously always happy to reach out.
Great, thank you. I'm sure they will do. It's a fascinating look at how you map competencies, how competencies are made up of skills and experience, and how that translates through to the R&D sector. You mentioned early on that the ECITB side of things have got training relevant to specific industry skills there, as well as RICS and the quarrying industries are very much looking at sort of the best practice side of things. It's good to see this happening in the R&D world too. And again, it is that very niche area that you spoke of. I very much like the attitude, the attitude towards the professionalism of the pilots that you're using, which gives them further skills as well, makes them incredibly employable along the way as well. So hold on to them or risk losing them to others. And I think that's going to, right across the board, improve the professionalism. It will enable missions to happen safely. It'll enable, as you say, sort of the test flights, the test days for business customers to run more smoothly as well. Obviously, there's the come up at the basis and at the bottom of all of this there is that commercial risk. Will this, won't this work? And I think you seem to have addressed everything there really positively and really constructively. So well done. I like further that it's a live document that you're further building on as you go through. It's a very good attitude, and it's a very positive one to see being enacted by yourselves, and then obviously in your consultancy phase to be able to be enacted by other organizations then too. That's really good. So well done. Across the board there. Does anyone have any further questions at the moment that Zack, yes, we will absolutely share your contact details alongside the Watch Again link so that people can get in touch with you directly. Please do ask questions now. This is a really good place and time to do so because we have Zack here, ready and waiting to answer your questions. Am I right in thinking that this presentation was sort of based on one that you started at DroneX?
Yes, yeah, we had to take a few slides out because I think you get a bit less time at DroneX, but it's largely the same presentation.
Excellent. Great. Well, I'm glad you've got a good audience there as well too for talking about this as well. As I mentioned, this will be up on both our website and YouTube sort of later on today, tomorrow, and available to watch again. Don't forget also that there are further webinars coming up this autumn. We have one in 2 weeks' time with InView assets looking at the differences between proactive and reactive maintenance. A very useful topic. If we have no further questions, I shall finish now and enable everyone to sort of go and find a sandwich for lunch and take it forward from there. Thank you very much indeed, Zack. I think that was such a straightforward presentation of what you've put together. Not the actual presentation bit, but you've thought it through so competently yourself that nobody has huge questions there. I think it's definitely an area that will then be easily transferable through to a multitude of industries as well, improving on the professionalism and therefore also the sort of the employability of drones and the trust in drones as well going forward. Is there anything else you would like to add about this?
There's not tons. I didn't touch on aspects of currency or training, but those are kind of separate items, tangentially related, but with sandwiches on the mind, I won't get into them. So yeah, I'll sort of leave that as a sort of a hook for people if they want to chat more about those aspects.
Indeed. So I take it they are sort of very much aspects that you've considered in conjunction with this as well.
They are, and again, using like those examples of like things that happen and what we think the competence should be. It's the example of, you can take your DJI M30, click the button, it does an auto takeoff, it will hover in place for 40 minutes, and then once it runs out of battery, it will land. You've got the 40 minutes currency, but you've not necessarily got the competence or actual experience that goes alongside that. So that's sort of why I say it's sort of tangentially related. Also covered in the documents that we've put together, but not presented on here.
Indeed, they will be, highly relevant side of things as well to go with this. Lovely. Well, thank you very much indeed for your time today and for the presentations. Absolutely enthralling. This will go out to everyone very shortly, and please do contact Zack for further information about it. Okay, thanks very much indeed then, everyone.
Well, thanks very much. Bye.
Bye-bye.